Hi, welcome to our Intro to CAD Suspension Mechanism project.
Suspension, or at least the concept of suspension, dates back as far as 61,000 years ago to the simple bow, which uses similar concepts, with some of the early versions of it being traced to ancient Egypt around 1300 BC in vehicles like chariots and weapons like the catapult. One of the early designs of suspension that is still used in some cars today is the leaf spring, which comprised of multiple sheets of metal stacked on top of each other in assorted sizes. But this form does not allow a wide range of motion and could not be tuned well to fit specifications. The other, more widely known suspension design is the coil spring, created and patented in 1763 by Richard Tradwell, and based off Hooke's law, which explains the behavior of an elastic body under stress. While initially unused, the coil spring was eventually integrated into cars and other objects such as armchairs from the 19th century onwards, thanks to the Industrial Revolution creating better, more efficient production.
As mentioned, the coil spring works on Hooke's law, which describes the behavior of a spring and provides a formula for its force. The energy from impact of the object's mass and the ground is stored in the springs. The amount of stress that the spring can take depends on the factors like material of the spring as well as the coefficient provided by Hooke's law. The damper on a spring works as an opposing force that dissipates the energy of the weight acting on it, preventing it from bouncing uncontrollably by converting it into heat energy. These two objects, in conjunction, make up the basis for modern-day suspension.
The applications of suspensions range widely from appliances to weapons, but the most common application that comes to people's minds is car suspension. The system of springs, shocks, and dampers attributes to a smoother ride for cars as well as better handling for braking and turning. The suspension distributes the weight evenly across the car, minimizing the impact on rough surfaces or sudden small bumps on the highway to both the passengers in the car and the car itself. When braking, the suspension in the front tires in a car must compensate for the additional force, or else a car might flip or turn over from the action. Other non-commercial vehicles such as race cars have special calibrated suspensions which accommodate the extreme force and speed that they endure during races. Otherwise, those turns in those sports would be impossible.
With the design of our suspension mechanism, we chose to go for an independent suspension system. So in the animation, it shows an applied force to either side which will work independently to absorb the impact. The force is absorbed by the shocks, its damping system with the spring component, and the pivot travel of the top and bottom arms. Both arms are fixed to the diff box and the wheel hubs, while the shocks are fixed to the bottom of the control arm and the shock tower to contain the impact. Thank you for watching.